Start. Hello students. Last class we discussed that is elastic collision as well as inelastic collision. Okay. Now in this class I will discuss that is gravitation as well as mechanical properties of solid as well as liquid and thermodynamics. Okay. I will begin with gravitation. What is the gravitation? Okay, you heard in school level you not studied this, but you heard the gravity. Yes. You know the gravity, acceleration due to gravity, that is 9.8. But here I am defining the gravity, that is Newton's universal gravitational law will define. Then again I will define acceleration due to gravity. Here gravity is nothing but the every object in the universe attract every other object with a force which is called what we call it as gravitation. Simple. That is here consider two objects will consider. Any two objects will consider, right? M1 of mass M1 and M2 separated by a small distance. Yes, in between these two a force is present. That is known as what we call it is gravitation. Gravitation is what? Gravitation. Yes. Okay. This is the concept of gravitation. Here, a very important law is defined. That law is Newton's law of gravitation. What is Newton's law of gravitation? Same concept. Here will be two masses, right? M1 and M2, separated by distance r. Right? These in between these two forces present. That is only a force of attraction is present. What type of force is present? Force of attraction. That is why force is denoted by F. We know that force is denoted by F. The force of attraction between how many masses are there here? Two masses. The force of attraction between two masses M1 and M2 is directly proportional to how it is related to force directly proportional to product of its magnitude M1 and M2 inversely proportional to square of distance between them. What is that? Square of distance between them is known as what we call it is Newton's law of gravitation. What is the Newton's law of gravitation? The force of attraction between two masses M1 and M2 is directly proportional to product of its magnitude and inversely proportional to square of distance. Okay, but here always students, this is a proportionality constant. Now I will remove the proportionality constant. F equals to G. What is the value, students? Here proportionality constant is removed by G. M1 M2 divided by R square. M1 M2 divided by R square. Okay, what is mean by G, students? What is mean by G? G is universal constant. What is the G here? G is universal constant. What is the value? That is 6.67 into 10 to the power of minus 11. What is the value? 6.67 into 10 to the power of minus 11 Newton meter square per kg square. What is the unit? Newton meter square per kg square. So it is Newton meter square per kg square is the unit. Okay, students, remember. Okay, I hope you understood what is the Newton's law of gravitation. Here Newton's law of gravitation, the gravity varies. What happens, students? The gravity varies. This one will play the major important role. Then the gravity will varies. Again I will discuss that. Here the statement, the force of the gravitational force is the attraction between the force of attraction between M1 and M2 is directly proportional to product of their masses and inversely proportional to square of separation distance is known as what we call it is Newton's gravitational law. Yes. Okay. I'll move to the next one here. The impact. What are the impact of gravitational forces, students? Very important, students. The impact of gravitational forces here. First one, the gravitational force is central. What is the central as well as conservative force? It is central as well as conservative force. It is central as well as conservative force. Next one, it is weakest force in nature, which is weakest force in nature. In first class I will explain to you, there are four fundamental forces are there. In the fundamental forces, one the weakest force is gravitational force is the weakest force, right? Next, the law of gravitation is applicable for all the bodies. It is applicable for all the bodies, irrespective of their sizes. It is not depends on any size and shape of the body. Yes, I hope you clear. Remember the points of gravitation. Okay, now I'll move to the very important point: acceleration due to gravity. What is means acceleration due to gravity? What you are calling the value of g? What is the value of g? Can anyone remember this value? Yes, the value of g is just first we'll define. That is the uniform acceleration produced in the freely falling body object due to gravitational pull of the earth is known as what we call it is acceleration due to gravity. Okay, I will take one simple example, students. Here students, last one example I given. I will consider tree. In the tree, apple is there, right? If this apple falls towards the ground, yes, why it is falling? Yes, something is attracting or not? Yes, which one is attracting? When you are moving on plane, otherwise when you are moving on any object, in a higher object, then suddenly engine stops. What happens? You also get fall. Why? Because why we are not flying? Why only we are falling? Because the acceleration due to gravity will pull in a downward direction. That is nothing but g will pull in a downward direction. At what speed it will pull, students? That is 9.8 meter per second. 9.8 meter per second. The gravitational will pull in a downward direction. Yes, okay, but this gravitational will varies. The gravitational acceleration due to gravity will varies. When we move above the earth surface, the gravitation start decreases. Yes, when we move below the earth surface, again gravitation start decreases. Yes, that's why here consider earth, right? In this earth, this is center and this is on the surface of the earth and this is above the surface. Yes, what about the gravitation on the surface of the earth, students? Gravitation on the surface of the earth is 9.8 meter per second square. Okay, g acceleration due to gravity, meter per second square. Yes, next, when we move below the earth surface, move towards the below the earth surface, what happens? The acceleration due to gravity start decreases. Yet exactly at the center, acceleration due to gravity is 0. Yes, when we move above the surface, again what happens? Again acceleration due to gravity is increases. Decreases. Again decrease. But where it is maximum? It is maximum exactly on the surface of the earth. This acceleration due to gravity is maximum. Okay. Now here it is denoted by g. How we are denoting? Small letter g we are denoting. What is the unit? Meter per second square, and it is a vector quantity. Okay, and its dimension is L raised to 1 and t raised to -2. Yes. Next, orbital velocity. Why I am defining the orbital velocity, students? See, orbital velocity plays the major role. Here artificial satellites we are launching, students. What we are doing? Artificial satellites we are launching. Those artificial satellites will revolve around the earth. Otherwise, moon revolves around the earth. Yes, these are what having certain velocity. What is having, students? It is having a certain velocity. That velocity, what we call it, is orbital velocity. What is orbital velocity? Orbital velocity of a satellite is the minimum velocity required to the satellite into a given orbit. How it is revolving? See, here will be This is a surface, Earth surface. Some moon is revolving around. Moon is revolving around the Earth orbit. Yes, that is moon is a satellite. What we call it is. Otherwise, here artificial satellite also we can take students. Okay, now it is revolving around the Earth surface. That time it requires certain minimum speed. What it requires? It requires certain minimum speed. That minimum speed is known as what we call it is a orbital velocity. How much is requires orbital velocity? That is 7.8 kilometer per second. How much? 7.8 kilometer per second. It requires. Just remember. Here, next one, escape velocity. Yes, the rocket escape from the Earth surface, Earth orbit, and how much speed it requires? Yes, it requires certain minimum speed. The minimum velocity, that minimum velocity required to escape from the Earth orbit is known as what we call it is escape velocity. This requires here escape velocity on Earth, the minimum velocity with which the body has to project vertically upward from the Earth surface is known as what we call it is escape velocity. How much it requires, students? It requires 11.2 kilometer per second. By blinking your eye, it will escape from the Earth surface. 1 second, within 1 second, how much time you take by blinking your eye? Within that short period of time, it escapes from the Earth orbit. Yes or no? That is known as what we call it is escape velocity. Okay. Regarding this, okay, I think school levels you not studied this gravitation. Yes, only some concept I explained. This all the concept, okay, inside the Earth, above the Earth surface, how it is varies, as well as what escape velocity and how it to overcome that, everything we'll study in first PUC classrooms. Okay, I hope you clear escape velocity. Okay, students, I move to the next one. That is matter. What is that, students? What is mean by matter? You know that classification of matter. If I ask the classification of matter, how many are there? 3. Yes or no? What is mean by matter? Anything which possesses mass and occupies the space is known as what we call it is matter. Any object, you can say this is a matter. Yes or no? Which it occupies the space. And having a mass is known as what we call it is a matter. Yes, the classification of matters. In classification of matter, there are 3 types. First one is solid, liquid, and gas. You know what is solid? Okay, it is the type of matter. Which has definite shape, and definite value. Is known as what we call it is solid. Yes or no? See, this pen is a solid state. Yes, this solid having a definite shape and size is known as what we call it is solid. Yes or no, students? Then what about the liquid, students? The liquid, it is the type of matter. Which has definite value but not definite shape. Okay. When we put a liquid in a different container, it occupies that position. So no, that's why it don't have definite shape. Okay, but it has the value. So no, students. Okay, that's why what we call it is a liquid. What about the gas, students? This is a type of matter which has neither definite shape or nor definite value. Okay. If you take a balloon, okay, you blow it, then it having a proper shape. Otherwise, our surrounding here it's having different shape. No. Yes or no? It neither. When you provide it occupies. When you not providing, it not occupies. You occupy that is known as what we call it is a gas. Yes, clear? Okay. Here I'll move to the next one, that is intermolecular force. Yes, here shows this pen is a solid icon, but the arrangement of pen, this matter is made up of atoms. How it is arranged? The matter is made up of atoms. Yes or no? Yes. But this matter is made up of atoms. In between these atoms, a force is present. Okay, I will take us clearly here. Yes. Okay. Here. One atom, in here one atom, all the corners, just assume the atoms. What is the difference? All the corner atoms are there. Yes? Okay, now, in the atoms, from this atom to this atom, this atom to this atom, between that, a force is present or not, as students? Yes? To hold it, If there is no force, otherwise, if there is no force, what happens? It get a disperse. ಇದರ ನಡು ಫೋರ್ಸ್ ಇಲ್ಲ ಅಂದ್ರೆ ಏನಾಗ್ತದ ಡಿಸ್ಪರ್ಸ್ ಆಗಿ ಹೋಗ್ತದೆ ಬಟ್ ಇದರ ನಡುವೆ ಏನೈತಿ ಫೋರ್ಸ್ ಐತಿ ಇವೆರಡರ ನಡುವೆ ಫೋರ್ಸ್ ಐತಿ ಹೌದಾ ಅದಕ್ಕೆ ಏನಾಯ್ತಿ ಅಟ್ಯಾಚ್ ಆಗಿದೆ ಯಾವ ಫೋರ್ಸ್ ಐತ್ರಿ ಇಂಟರ್ ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಯಾವ ಫೋರ್ಸ್ ಐತಿ ಇಂಟರ್ ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಡ್ಯೂ ಟು ಇಂಟರ್ ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಏನಾಗೈತಿ ಹೋಲ್ಡ್ ಆಗೈತಿ ಸೈತೆ ದಟ್ ಈಸ್ ಇನ್ ದ ಶೇಪ್ ಆಫ್ ಅ ಸ್ಪ್ರಿಂಗ್ ಸಿಸ್ಟಮ್ that is the shape of a spring system. If I apply a very large force, it gets small, it gets compressed. Yes, again I release it, again it can come back to its original position. Yes, same thing. All the atoms are arranged in a spring structure. How it is arranged? Spring structure. That in between this, the force is present. That force is known as what we call it is a intermolecular force. Yes, that is intermolecular forces. Now intermolecular force is defined as what? That is the arrangement in a such a way that molecules is acted upon by the force due to neighboring molecules is known as what we call it is a intermolecular force. Yes or no, students? Yes. In between this to this as well as this to this, all are having a certain amount of force is known as what we call it is a intermolecular force. Okay, this concept also will in detail we will study in a first year syllabus. Next one, elasticity. Okay, elasticity as well as plasticity. Students, I will do an example. Normally you are using a rubber. Yes, I will stretch it, students, again I will release it, again it comes back to original position. Yes or no? Yes. Okay, same thing. I will consider plastic. I will stretch it, students. Again I will release. Again it comes back to original position. Yes, it can't come back to its original position. Yes. What is mean by elasticity? That is nothing but the property by virtue of which the body tends to recover its original position by deforming the force is known as what we call it is elasticity. I will give an example, students. Assume this is the rubber you assume, students. I will stretch it. Okay, it expands. Again I will release it. Again it comes back to its original position. Yes or no? Okay, such a body is known as what we call it is elasticity. Yes, in which is the most elastic body here, students? Which is the highest elastic body? Steel, students. You can ask, sir, how it is steel? Yes, because maybe you heard the controversy in a steel bridge, because the steel bridge having the highest lifetime, students. Because by applying force, it deforms. It gets. See, assume this is the bridge. If you apply the force, it bends. Again, when vehicle will move, again it comes back to its original position. That's why steel is the highest elastic property. Yes or no? Okay. Next, plastic. What is plastic? By applying force, the body does not come back to its original position. I'll consider on plastic. I will stretch it. Again, I will remove the force. Both side force I will remove. Again, it will come back to its original position. It's never come back to its original position. Such a body is known as what we call it, students, plastic body. That's just I will define the definition. The body which do not shows any tendency to recover their original configuration on removal of deforming force is known as what we call it is a plastic body. Okay, when you remove the force, it not come back to its original position. Such a body is known as what we call it is a plastic bodies. Okay, now here one concept, the stress and strain. Okay, first I will define the stress. What is stress? Here consider Students, here you consider anyone, a body, any shape of any body, okay? Any body you can consider, students. In this any body, I will apply the force. What I will do, students? I will apply the force. But where I am applying the force, students? This is the F force I am applying. Where I am applying? I am applying in particular area I am applying. By applying the force, what happens? It get compresses. What happens? It get compresses. This is original length. This is original length. By applying force, what happens? Its length get changes. It get compressed. If I am applying both the side opposite force, say this is, yes, this way I am applying the force as well as this way I am applying the force. But this is original length. What happens? Here it get expands. Here what happens? Here it get compressed. Yes or no? Here it get expands and here it get compressed. That time expanding as well as compression takes place when? By applying the force. Where we are applying the force, that is nothing but in a particular area we are applying the force. That is stress equals to force per, stress equals to force per unit area. Stress equals to force per unit area is known as what we call it, students, stress equals to force, restoring force per unit area. That is restoring force per unit area is known as stress. Clear? I hope you clear. Then when we apply the stress, one example I will do. When students you are having a nearer exams comes to very nearer, then you feel very stressed. You will tell to your mother, yes, so madam, mother, I am feeling very stressed. Why? Because the exams are very near. Okay? Even at the time taige, stress agate anta ಹೇಳ್ತಾರೆ. ಹೌದು, ಯಾಕೆ ಸ್ಟ್ರೆಸ್ ಆಗುತ್ತೆ? ಎಕ್ಸಾಮ್ ವೆರಿ ನಿಯರ್ ಇದೆ ಅಥವಾ ರಿಸಲ್ಟ್ ಬರತ್ತೆ, ಅವಾಗ ಸ್ಟ್ರೆಸ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ. So no, when in August month your result is released, before one day what happens? Again you feel the stress. Why? Because some pressure is acting, right? That's why stress is nothing but force per unit area. Okay. Now another one is strain. Strain is nothing but what? Now by applying the stress, that length get changes. What happens is length get changes. The change in length to the original length. Change in length to the original length is known as what we call it is strain. Change in length to the original length is known as strain. Strain is nothing but change in length to the original length. One example I will show. This is initial length L, right? By applying force, what happens? Its length get decreases. That is delta. Yes, that is nothing but change in length to the original length is known as what we call it, students, strain. Okay, but this stress and strain concept was explained by one of the scientists, Hooks. The scientist Hooks, that is very important, Hooks law, because it will help to study the properties of materials. Okay, here Hooks law. What Hooks law states? That is stress is directly proportional to strain. Stress is directly proportional to strain. It states that within an elastic limit, stress is proportional to strain. That is stress is proportional to strain. Okay. Now this proportionality constant is removed by K. Value is K. That K is nothing but what? Modulus of elasticity. Okay, modulus of elasticity, different modulus we are studying, that is Young's modulus, bulk modulus, sharing modulus. Okay, these are the different modulus we are studying in a class, first PUC class 1 will study students. But just remember what is Hooke's law. The stress is directly proportional to strain. When we apply the stress, what happens? Simultaneously strain also get changes. So no, that related stress and strain are both are related forms of force explained by Hooks. Yes, I hope you clear. Okay, next one, steady flow. Okay, in steady flow, what is steady flow? It states that, okay, any liquid I will consider, students, I will allow the liquid, it start flowing. Okay, it start flows with, steady means Okay, regularly, continuously. Study means what? Regularly. Or another what we call it is a streamline flow. Also we call it streamline flow. That I will define here first. It is the flow in which velocity of fluid, particle crossing a particular point at all the time is known as what we call it is a streamline flow. One example I will use here. Here consider this is the pipe consistence. Okay, in this pipe we are allowing the liquid. What we are allowing, students? We are allowing the liquid. Yes, this is point A, point B, and point C. Yes, the liquid is flowing point A to point B, point A to point B. 2 meter per second it is flowing. 2 meter per second it is flowing. Then again, what about point B to point C? Steady means what? Same, continuous. Again, here also it will flow 2 meter per second. 2 meter per second. Such a flow is known as what we call it is a streamline or a steady flow. What we call this streamline or steady flow. Every point A to B, B to C, as well as C to D, every point velocity is same. Is known as what we call it is streamline. Yes, I hope you clear. Turbulent flow students. Okay, turbulent flow is what? In turbulent flow, the velocity is different. Again, I will consider container, right? Pipe I will consider. In this pipe, A, B, C. Liquid is flowing. Yes, liquid is flowing. Here, A to B velocity is 2 meter per second. Yes, again B to C. When again it comes to point B, that time it 3 meter per second. Again C, 4 meter per second. But what happens is every time velocity get changes. Velocity get changes. Such a flow is known as what we call it is a turbulent flow. Okay, next, thermodynamics. What is thermodynamics? Thermodynamics is a branch of physics. It is a branch of physics which deals with study with processes involving what are those heat, work, and internal energy. Heat, work, and internal energy is known as what we call it, students, thermodynamics. What is thermodynamics? It is a branch of physics which deals with study of work, internal energy, and heat is known as thermodynamics. Okay, this concept also again we are studying in our PU level, but here a brief syllabus on cover, students. Okay, what are the major parts? Okay, that is important for our upcoming studies. Next one, thermodynamic processes. What are the thermodynamic processes? A process by which one or more parameter of thermodynamic system undergoes changes is called thermodynamic process. So what is the meaning of thermodynamic process? An example I will give. I'll consider a container. Container is filled with water. I start heating. When containers start heating, before heating, you measure the temperature. That is around 27 degrees Celsius. When you start heating, it goes to 100 degrees Celsius. But what are the quantities are changed, students? What are the things are changing? Yes, internal energy changes, students. Pressure changed, temperature changed, as well as volume also changed. Yes or no? How many quantities are changing? Pressure changing, temperature changing, as well as internal energy changing, and volume also changing. Yes, these are the parameters are changing. Such a change in parameter, what we call it is a thermodynamic process. What are the thermodynamic processes, students? Different thermodynamic processes we are studying. Okay, I'll begin with first one, students. That is isothermal process. What is that? Isothermal process. In isothermal process, what are the changes constituents? The process in which change in pressure and volume are changes, but constant temperature. Temperature is what, students? Temperature is constant. Only just pressure and volume changes. Such then temperature constant. Such a process is known as isothermal process. Yes, next one. Isobaric process. In isobaric process, the process in which change in volume and temperature, but pressure is kept constant. Such a process is known as what we call it is isobaric process. Getting? Okay. Next one. This also we will study in detail, students. In detail we will study in Q level. Next, adiabatic process. Okay, thermometer. That is thermos. Okay, when you put a T on it can't affect. That is, T is hot only up to the 12 hours because that is in whole surrounding is evacuated with the adiabatic process. In adiabatic process, in the process in which pressure and volume and temperature takes place without any heat entering or leaving. Yes, I'll consider thermos. In thermos, if I put a hot tea, yes, that hot tea can't exit from surrounding surface. Here, this is the container textures. Okay, in this container completely filled with the hot water. Then here atmosphere, surrounding atmosphere. Whatever heat is not losing as well as whatever heat it is not gaining. Okay, such a process is known as what we call it is adiabatic process. Such a process is known as what we call it is adiabatic process. It is not exiting any heat as well as it is not gaining any heat. Okay, such a wall is created. That wall is known as what we call it is adiabatic wall. We call it is adiabatic wall. That is known as adiabatic process. That's why change in pressure, volume and temperature without entering or leaving heat, which is not entering as well as leaving, heat is not entering and leaving, is known as adiabatic process. Okay. Here last one. Okay, first law of thermodynamics. What first law of thermodynamics? The first law of thermodynamics states, students. Okay. It states that the change in internal energy of a system equals to net heat transfer to the system minus net work done. That is nothing but here. Net work done is known as what we call it is its internal energy equals to net heat transfer minus work done is known as what we call it is first law of thermodynamics. Very important questions. Just I am stated the first law of thermodynamics, but it is very important here. What are the quantities are changing? Again it's having directions also. It's having the direction also we can discuss, but not now. When you enter to the first PUC class, we can discuss the directions also, students. Just I will state. Internal energy is denoted by U, heat is denoted by Q, and work done. Okay, here just I'll take on containers. This container is filled with the liquid. Yes, if I start providing the energy, what I am providing here? Internal energy I am providing this. Here, what happens? Work is done. How the work is done? The molecules are interacting. That is intermolecular. That is internal energy is changing. That is the internal energy is due to what? Here work, amount of heat is supplied and work is done. That is nothing but what we call it is internal energy, or we call it is the first law of thermodynamics. Okay. Next one, last one. That is the formula. Heat engine. Heat engine is defined as it is device used to convert heat into mechanical energy. Heat into a mechanical energy is known as what we call it is a heat engine. Starting first slide, video I explained to you. First development is taken by heat engine. Yes or no? Yes, that heat engine is revolutionized whole world. So that is nothing but heat engine is a device to convert heat into mechanical energy is known as what we call it is heat engine. Yes, in the heat engine we are studying a Carnot cycle also we are studying, as well as refrigerator also we are studying. A different concept we will study in the first students, but just I will define the heat engine. You remember the formula, work done equals to Q1 minus Q. Okay, I hope you cleared. I've explained up to students. Thermodynamics I explained completely. Thermodynamics brief introduction I explained. Okay, next class I will explain wave and oscillation. Okay, frequency, time period, amplitude. This concept I will explain, as well as some of the charge particles. Okay, some of the charge particles microscopic level I will explain. In the next class I will explain. Thank you, students. Support us, watch our videos, and inform to your friends also. Okay, thank you.